Let's solve this problem involving percents. 12% of what number is 75? We're going to translate this problem into a missing number statement. And then we're going to use the missing number statement to help us decide how to solve the problem. Let's go ahead and translate. 12% of, well, percent of, I can always think of as percent times. This is 12% times, next comes what number? For what number, I'm going to write a box. The box represents the number we're trying to find here. 12% times what number is, the is I can replace with an equal sign, is 75. I'll write the 75. Now here, while this problem is worded using multiplication, I'm missing one of the two numbers to multiply. 12% times what is 75? Because I'm missing one of the two numbers to multiply, we're going to have to divide to get the missing number here. But before we divide, we need to convert the 12% into a number without a percent sign. We need to get rid of that percent sign. Now, to get rid of a percent sign, what we do is we divide by 100. So with 12%, to get rid of the percent sign there, I'm going to take 12 and divide by 100. Now, there are a couple different ways we can do this. One way is to think of 12 as a decimal number and take a shortcut. Now, 12 is a whole number, and any whole number has a decimal point that's understood to be at the right corner, at the right end of that number. Dividing by 100 amounts to moving that decimal point 2 places to the left. So it would end up right here in front of the 1. So 12 divided by 100 is the same as the decimal 0.12. Another way I could obtain 0.12 here is to do decimal long division. I could take the number 12 and divide by 100 like so. You can use long division if you forget the shortcut or if you forget which way to move the decimal point in the shortcut. So let's go through the long division and see what happens here. Now 100 doesn't go into 1, doesn't go into 12. At that point, I need to put a decimal point inside and also up above in my answer. I can then add a 0 on the end and think about 100 going into 120. It goes one time, so I write a 1 up above to the right of the decimal point. 1 times 100 is 100. 120 minus 100 is 20. I can now add another 0 on the end and bring it down. 100 goes into 200 2 times. 2 times 100 is 200. Subtract, I get 0 remainder. So I'm done with the division. And my answer to the division is 0.12. That's the same as the 0.12 we got here by moving the decimal point. Now let's go back and actually do the problem. 12% we now see we can write as 0.12 times box, the number we're trying to find, equals 75. Now, as I said before, because we're missing a number to multiply, we're going to divide to find the answer. But in order to set up the division problem, we need to be careful about which number we write first. The equal sign in the multiplication problem separates the multiplication problem into two parts. There's the multiplication part of the problem on one side of the equal sign, And there's the answer to the multiplication on the other side of the equal sign. When we divide to find a missing multiplier, the answer to the multiplication has to go first. That's the number all by itself on one side of the equal sign. So here I'm taking 75 and dividing by 0.12 to get our missing number. Because a decimal is involved here, I'm going to do decimal long division. In the long division process, the 75 goes inside the long division box, and the 0.12 goes out in front. When I'm doing long division with a decimal out front, I need to move the decimal point over to the right. In order to not change the problem, I also need to move the decimal point inside the long division box. Now 75 is a whole number. Its decimal point starts out just to the right of the 5. When I move the decimal point 2 places to the right in 0.12, I also need to move the decimal point 2 places to the right from where it is inside the division. In order to do that, I need a couple of zeros here so that I can move to the right of those 2 zeros. And in fact, in my final answer, my decimal point will end up right above the new position of the decimal point inside the long division box. Now we're ready to go through the long division process. I'm thinking of 12 into 7 first, doesn't go in. 12 into 75, well, let's think about that a bit. Let's try some possibilities. What about 12 times 6? 6 times 2 is 12, carry the 1. 6 times 1 is 6 plus 1 is 7. 72 is very close to 75. In fact, that's about the best I'm going to be able to do. 12 times 7 will be too much. So let's write here 6 above the 5. 6 times 12 is 72. And subtract 75 minus 72 is 3. Now I need to keep going until I get all the way to the decimal point in the answer. I need to bring down a 0 and ask myself, how many times does 12 go into 30? 12 goes into 30 2 times, right? 12 times 2 is going to be 24. So I'll write a 2 here above this 0. 2 times 12 is 24. Subtract 30 minus 24 is 6. And I still have one more 0 to bring down, the 0 on the end here, just next to the decimal point. How many times does 12 go into 60? Well, let's see. I know it's going to be less than 6 because 6 times 12 is 72. Let's try 5 times. 12 times 5. 5 times 2 is 10. 5 times 1 is 5 plus 1 is 6. It's 5 times exactly. 5 times 12 is 60. 60 minus 60 is 0. And we're now done with the long division because we got all the way to the ones place just next to the decimal point. So my result here is 625 point, which is the same as the whole number 625. That's the answer to our problem.